Okay. All right. So this is I think I'll share this repository after the because the code and everything would be here. So this is the repository where I did the image segmentation in. This is the README file now. I also did the ResNet assignment, but I'm not going to focus on that. So I'll be talking about what unit is, what image segmentation is, and I'll go to the code and how it works. All right. Firstly, hope we can hear me clearly. All right. Yes. All right. Thank you very much. Okay, so um, down to the description. In this project, um, I trained an image segmentation model using Unit++ architecture. So for the units, because I did ResNet, but we're going to leave that out because that's not our focus for today. So focusing on the Unit++ now, um, I encountered several issues on um, the issues pertaining to the kind of unit architecture I was using, the incompatibility of libraries, all the libraries used for running the model. And I encountered some issues with running it on my local system. Till today, I don't know what those issues were, but I found out that it's actually much better to do this on the cloud. So I use GitHub Codespaces. You could use Collabs, you could use Azure if you have access to those good as Google Collabs and Microsoft Azure. If you have, I use Codespaces and I use a CPU, and that's important to note because Unit is usually run on GPUs, but I don't have access to that kind of um, hardware or cloud um, provision. So I um, used another problem I encountered were the skip connections receiving different dimensions of inputs. Like I had that one a lot, but that was closely related to the kind of architecture I was using. So my issue was that I was trying to make um, a unit structure, a unit architecture, that's the code from the scratch. And one thing I must say is that I tried using ChatGPT, and if you're using ChatGPT to generate the code for units or Unit++ or image segmentation, it's not going to um, it's not going to give you a correct code, and that code is going to have a lot of um, problems. So that's what um, those are the problems I faced, and um, I'll address those problems in this presentation. So thankfully, I found a repository on GitHub that helped me to a great extent. Though I had to do some debugging and recoding to train the model, also to um, help it to work with CPU instead of GPU, like graphic processing units, because that's I had CPU. That's what was available to me. So if you get the code from my repository, this repository I'm presenting from, you might want to tweak it to run on a GPU if that's what your system or or the cloud space you're using has. Okay, so what is Unit++ and how does it work? So I'm going to firstly zoom in here. So we can see these two images. There's the unit, this one, and there's the Unit++. So Unit++ is an extension of the original unit architecture. It's designed to improve image segmentation tasks. And I'll say this now, image segmentation is basically, um, for instance, let's say this unit is a baby, right? A baby that has never seen a cat. When you bring a cat into the house of a 2-year-old baby, the first time the baby sees the cat, it recognizes that cat and it registers in its mind. But if you bring, because there are some cats that don't have fur, that don't have hair on their body, and they look, in my perspective, really ugly. So if the mother of that baby brings a different cat, to that 2-year-old child's, house, when the child sees the cat, he might not see it as a cat. It might be wondering what it is until the mother tells it specifically that, okay, this is also a cat. So the mother is training the baby to recognize what a cat is. Now, image segmentation is similar to that. Image segmentation is when you train a model to recognize a foreground in the midst of a background. The foreground is the cat in this my example. The background are the other things in the house: the TV, the chair, the floor, the tiles, and all that. So image segmentation is that you are training the model to recognize, to segment, to separate the cat from the other things in the background. And that is what Unit++ is good at, image segmentation, right? So image segmentation is good on Unit++. Why? Because of these green, can we see these green skip pathways? Yeah. So these green skip pathways are the additions to the unit model that makes it Unit++. Or we can also call it nested unit because of these dense skip layers or pathways. So that's Unit++. It's the architecture helps to better capture fine-grained features and improves the accuracy of the segmentation. So they initially introduced it for medical imaging because they needed a more accurate segmentation model, so that medical imaging requires a lot of detail. So the unit wasn't doing so well, but it was doing well to an extent. But the Unit++ had a better ability to recognize, for instance, tumors, cancers, organs, different things, nuclei of cells, that's the nucleus of cells in the human body, and different things like that. So today, Unit++ is even used for computer vision. Self-driving cars use it to recognize people on the road, recognize the road, buildings, turnings, and all that. Yeah. So how does Unit really work? Now, every unit model you're training must have a data set, and that data set contains two types of images. You have the image, which is this. Now, in this model that I trained, this image is a scan of different nucleus in the human body, nucleus of cells in the human body. So these white dots you see here are what we want the model, the architecture and the model to recognize. The black space is the background. These white dots are the foreground. These white dots. So you have to have an image, and that data set also needs to contain masks. So masks are basically I would say the target variable. So when we pass this image, I'll explain that. When we pass this image into the unit architecture, we want it to generate a prediction. Now that prediction must match each of these coordinates. Now these are masks, right? Now what these masks are for are to show the coordinates of each of these nucleus in the image. So for instance, this big one here at this corner here, we can see its mask here, this white dot. So what this does is that when the unit predicts this particular, amongst others, predicts this particular one, it brings it and compares it with this ground truth. to see if the two images are similar. And if they are not similar, then it would calculate the loss and adjust its weight, do a backward propagation so that it gets the prediction right the next time. And that's how the unit keeps going back and forth. Okay, this is how the image looks like. It would make a correction, it would take the image this way, make the correction, take it back like that until it adjusts its weight properly and it's able to understand is able to easily recognize or segment these images. It's not in all cases that the image looks like this. So sometimes the image is just one particular object and then a background. Here we have several objects. So the methodology that you use to load this data will be slightly different from, say, when you're using fingerprints data or car data, image data, right? Are we still with me? Let me check. I'm still on the call, right? I guess so. Okay. So I hope we've understood it to this extent. So the data set I used was structured in a particular way, which is necessary to note, because if your data set is structured in a particular way, you need a code to actually extract the image and the masks appropriately, or else you get an error.
Sorry.
So, yeah.
Hello.
Yes.
Can you think like for one image, how many masks is used?
Okay, very good question. Actually, one mask is used, but this particular data set has it came with several masks. But I'll get to the code. In the code, we actually join all these masks together to form one mask. Let me just briefly show us. Here, this is so inputs. I'm going to show us now how a mask looks like. So this is the mask for this first. This is how the code works. Now let me show you the mask. Aha. So can we say? So it joins all this. The code joins all these masks together. The data set is a bit complex. Most data sets just have one mask for the image, but I had to use a code to join all these masks to just form one mask. Do you understand? And I'll show us later on. Is that clear? So we can see, if you compare the two images together, this one and this one, we can see the mask of this one is here, this mask for this one, and like that, and so on and so forth. So this data set was a bit complex. It scattered the masks to several. So the mask is usually supposed to be one, usually, especially in image segmentation tasks. So thank you for that question. I hope you understand to a degree. I'll still explain further. So I'm just pressing forward for time. Sorry. Okay. Can we still hear me? Someone's mic is unmuted. Thank you. So now we're going to move on to the encoder and the decoder of the unit. It's important to understand all these things so that we can easily